We now adjust the light in the scene one last time. The reason why the first two parts did not deal with the shader yet is that I wanted the results to be visible immediately when the shader is created. The other way around, it might have been frustrating if the shader was ready but not immediately usable. The technique of making the light source follow an object makes the placement and alignment of lights very convenient. The scene prepared in this way is ready to see and test the new shader immediately. Here is a preview of what the shader does. Depending on the settings and the solder, the diamond has nice fire in the reflections. The glass sphere can also be seen. One more thing I forgot, the scalings are not applied yet. The diamond and the center ball now get a new material. I prepare the view on the left so that I can see the changes in the material as soon as they are available. We start with a clean material shader and delete the two existing nodes with the delete key. The first node we need is the geometry node. I add this and all following nodes with the Shift and A key combination. The next node is the white noise node. Set it to 2D mode. Here we have the first part of the magic. The node uses the position data of the light rays and creates a white noise based on it. Now comes the color ramp node. Here it is important to make sure that the value output is connected to the FAC input. We use the color ramp to decompose the light into its natural spectrum. We don't just want to split it into R, G and B, but also the transitions in between. First check if the start and end point is completely set to black with alpha 1. Now create 3 more points with the small plus button and set one of the 3 new points to 0.25, 0.5 and 0.75 each. Set the colors to R, G and B respectively with the value 4, but note that blue is in front and red is behind. The color ramp then shows us the set colors and their correct transitions. Now a multiply node is needed, which is supposed to mix the color value of the light beam later with the configurable base color of the object. Thus the object can have its own color, and this is then also visible in the emerging light. Set the factor to 1. I overlooked that when I created it, but that will also be corrected later. Now create an RGB node. This will be the basic color of the object just mentioned. Initially, the color should simply be 100% white. Now we need a BSDF refraction shader. The shader takes over the correct representation of the refraction in the material. So that we can set the roughness later, we now create a value node and leave the roughness at 0 for now. I rename the value node to make it easier to use later. This is not really necessary. Now comes a very important value node for the material properties. This stores the IOR value. IOR means index of refraction. Each material has its own value. First set the value to 1.45, which is used internally for glass in Blender. It is really easy to search the internet for the correct IOR value needed. Nevertheless, I will show you an example. Now we need a normal map node. With this we can add an additional surface to the object. We also connect the normal map to the finaly node. The next node is the Fresnel node. This node controls the behavior of the diffraction. The time and my knowledge are too small to explain this in detail. If you are interested in the physical properties, you can find many sources on the internet. Connect the IOR value to the new node. Now we need a glossy BSDF node. This controls the glossy behavior of the material. We use this like a clear coat layer and can also give it its own color. In principle, the layer can also have its own roughness and normal, but I just keep using the existing values. Experiment with them a little later. I rename the RGB node to main color, so this is the inner color of the object. Now we create the RGB node for the clear coat, so this is the outer color of the object. Set the color to 100% white as well for now. Connect the color output to the color input of the glossy BSDF node. And combine the existing roughness and normal values with the remaining nodes. With the Mix Shader node we now combine the three properties Fresnel, Refraction and Glossiness into a new shader. It's time for a first test. Let's take a look at the material as it has been created so far. Creates a material output node and connects the new shader to the surface node. We haven't quite finished our new material yet, but it's already glass with some capabilities. What is still missing is the dispersion, but that will come in a moment. Now we need a RGB curve node. With this node we control how the coloring of the distortion is calculated. From the white noise node we connect the value to the color input of the RGB curve. It is important that you do not connect color to color. Then we move the node from the bottom left to the top left to 0 and the node from the top right to the bottom to 1. Click on the center of the line to insert a new node. Set the x and y coordinates to 0.3. The curve shows the future course of the distortion. We now need a map range node. Unfortunately, it's getting a bit confusing now, but we'll be done in a moment. Connect the color output of the RGB curve node to the value node. For a better overview I push the IOR node down on the left, replace the connection of the IOR in the refraction BSDF with the result output. The IOR value only for the refraction will be calculated dynamically via the map range node in the future and no longer fixed. Add a new value for the dispersion and rename it. Finally, we need a math node. This adds the IOR value with the desired dispersion. Connect IOR with the first value, dispersion with the second value. Then connect the result of the calculation to the toMax node. Connect the IOR value to the toMinimum node. We will be done shortly. For a quick test, I set the dispersion value to 3 to see if the output is correct. It is not. We will fix that in a moment. I initially forgot to set the map ranges. From minimum should be 0.5 and from maximum should be 3. Looks better, but still not correct. Here is the complete overview of the shader. Meanwhile, I am looking for my mistakes. I have found 2 errors. Number 1 is a wrong value in the multiplication of the main color. Here the value should be exactly 1. The second error is the clamp set in the map range node. Remove that. Now our new shader is complete and working as it should. At this point again my hint, the shader works in this configuration only, if you work with realistic sizes. Let's see how the diamond looks with the new shader. There is real fire in the diamond, but that is still too much, because we have not yet brought the IOR value to the necessary material value. But that already looks very good, I think. Now I'll quickly play with some material properties to show you what the shader can do. First the outer color, then the inner color. Combined this can deliver quite great results. You can find out more by trying it out. The light intensity is still too high here.